Okie dokie. My video cut out on Thursday's revision, so this is Friday's revision right here. So we were here, guys. We were at the very end of the area and perimeter. I just want to pick up on something here, okay? A square has a perimeter of 80. All the way around the square is 80. Because it's a perimeter of 80, I can divide it by 4 to work out that each side is 20. However, the question says, what is the circumference of the circle? Well, cherry pie is delicious. In the last video, yesterday's video, we were using that apple pies are 2. We were using that area is pi times radius squared. But actually, for the circumference of the circle, for how far it is around the circle, which is what the circumference is, okay, it's pi times the diameter. So why have they given us this? Well, that 20 is from there, isn't it, to there. So actually, that 20 is the diameter of the circle. So we're going to do pi 3.14 times 20. We don't have to square it or anything like that. That's for area. Pi times the diameter, whatever that is, round your answer to 1 decimal place. Fabulous. I believe that's the question, right? Volume. Volume. Same as area. However, you find the area of the front of the shape, and all you have to do is times that then by what the formula sheet calls the length. I do prefer the word depth because I've already used the word length for things like rectangles and stuff, so I prefer how deep. So there, for example, that is a depth of 20, that is a depth of 15. But we start with the shape at the front. So at the front of this one is a triangle, so the area of that would be 30. Then take your answer and times it by the depth, okay? Job to go done. Here, the front is a trapezium, okay? Top plus bottom, half it. Right, so half of 22 is 11 and times the height. Okay, I believe that's 66. Take your answer and times it by the depth. Take your answer and times it by the depth. These will be in centimeters cubed. I want to pick up on something now. A centimeter cubed, put this down somewhere. I think I've put this in a different booklet somewhere as well. A centimeter cubed is the same as a milliliter. They are the same unit. So if it says in a volume question, give your answer in liters, whatever, if, I don't know, let's do this one. Say this is 130, it's 1,320. So it's also 1,320 milliliters. They are the same thing. To change that into liters, I would need to divide my answer by 1,000. So it would be 1.32 liters. I'm not so worried about that. Right, you'd have to work out the length of the area of the front again and times the area by 8, and we've done, right, okay. However, the circle, the area would be pi times the radius squared, radius of 7, then we go halfway across the circle. You'd work that out, take your answer and times it by the depth. So we've done area, so volume should not be an issue, okay? Easy, not touching it, done it. Here, right? Now with cuboids, the area of the rectangle would be the length times the width, right? So actually, for cuboids, you might want to just not bother doing area and then times depth. You might want to just times them all together. So A is 6 times 2 times 3, right? And B is 2 times 2 times, don't know, they call it H. Oh, we'll go with H, okay? You are told that they have the same volume. Well, 6 times 2 is 12. 12 times 3 is 36, right? Equals 2 times 2 is 4. What does the height need to be so that this is also 36? So 36 divided by 4, so H needs to be 9. OCW again, so you might want to say the volume of A is 6 times 3 times 2 centimeters cubed. Got to get our units in the OCW. The volume of B is 2 times 2 times H. Right, okay. Therefore, H equals 9. You won't get away with 9 in an OCW question, though. 9 centimeters. Okay. So it's a bit of volume for you there. Right. Pythagorean trig. We're going to need a calculator. This is paper 2. Don't revise this for Monday. Okay. Some notes on it there. Here. You're looking for right angle triangles in paper 2. Right angle triangles in paper 2. Nothing to do with don't it's so easy to confuse it with an angles question, where they give you an angle and ask you for the other angle, but it's not, right? Read the question. Calculate the length of Q to R. We want this. In other words, we know this side, we know this side, we want this side. That is Pythagoras. That is square, square. And because the side we want is the longest side, we need to add our squares together before square rooting. So to find the big side, square, square, add square root. Calculate the length of the side AB. Right. This time, we know this side, but this time we know an angle. Right. And the side we want is AB, which is this one. I always like to put an X on the side they ask for, okay? So there are the three. Now, this is SOHCAHTOA. This is SOHCAHTOA. As soon as there's an angle involved with sides and angles, it's not Pythag anymore, right? So let's label it. The big side is the hypotenuse. The angle opposite the angle is called exactly that. And the final side, we always label as the adjacent. So cross our SCT, which sides do we know? We know the hypotenuse. We know it's 13.8. Which side do we want to know? We're interested in finding out the adjacent. That's the one that the question's asking us for. Which side don't we know and don't we care about? The opposite, right? So it's not crossed out. So we're using car. What are we using car to find? That was my cat making that noise, not me, okay? Please don't walk all over the keyboard and make me start this video again. Okay, we're trying to find the adjacent, right? The adjacent. So to find the adjacent, it is equal to C, which on our calculator is cos, and it will do that. In there, we put the angle, and we close it. Then we times H, and H is 13.8. And whatever that is on the calculator, that's the answer. This cat is causing chaos. Don't forget. Right. There's always a problem, isn't it? This is me fighting a cat while I talk to you. Okay. Right. Here. Not going on there. Down you go. Right. That is the cat I'm talking to. Okay. The right angle triangle has an area of 84. There's got to be a reason they've given us the area. Possibly we need to know this, right? But we need to double this. And now that we know this, we got calculated for all this. We got to double this because its area of this is base times height divided by 2. So double that, it's 168. That is what I need to divide by 24 to get that side there. Okay. I don't know the answer to that. Let me quickly. 7. So this is 7, right? But the question says, we see it's really not obvious what they want to do. What's the perimeter of the triangle? Well, we've kind of worked out this is 7, and we know that this is 24, but we're still needing this to get the perimeter. We're going to need to do a bit of Pythag. Square, square, add, square root. We don't need the area anymore, right? We've used that to get the 7, but we can square the 24, square the 7, add them together, square root. Back to a bit of trig. Okay. Again, calculate the side MN. It's very similar to the last one, guys. That's the side we want. That's the adjacent. That's the hypotenuse. That's the opposite. Again, it's exactly the same as the one I just did. They are the important side, and that's the angle we know. So you're going to be using car again, okay? Calculate, right. Looks like Pythag, doesn't it? If the question said work that out, oh my God, but it doesn't. The question says calculate the size of Q, and as soon as you see one of these little roofs, that's an angle. Q, P, R, and the important letter is the middle one, which is P, okay? Hypotenuse. Because it's to do with an angle, it's trig. It's not Pythag is when we don't care about angles, okay? And adjacent. This time, though, ladies and gents, the opposite and the hypotenuse, and I'm going to do that in lesson on Tuesday before we go into the exam on Wednesday. I'm not going to talk about finding angles with trig now, okay? Same there, I'm not going to talk, and these, I'm not going to talk about them, okay? They're combined ones, same as this. I'm going to leave these for Tuesday, if that's okay, all right? Instead, similar shapes. I'll let you read the top one, but look here. Let's go to a harder one, okay? We need the length of RQ. RQ is this one here. Let's call that X. And LN. LN is on this shape. That's Y. Now, on this shape, Y is linked to 4.5. X is the same side as the 3.2. However, 4 and 6, I know them. They're a matching pair. They're a pair that I know. So it allows us to get a scale factor, 6 divided by 4, into your calculator. Normally in calculator papers, these, okay? 1.5. Therefore, to get X, I would need to take that number and times it by 1.5. And that's what I'm doing here. 3.2 times 1.5. However, to get Y, which is on the smaller shape, I need to take that and divide by 1.5. Okay, now you could do these without calculators, actually 1.5 ones, because how many 1.5s go into 4.5? Literally, like a times table, 1.5, 3, 4, it goes in 3 times. To times something by 1.5, right? 1.5 of those, so 3.2, and then half of that is 1.6. Add them together, you get 4.8, so there's 1.5 of those, but I would imagine you'd get a calculator. Okay, how long have I got left? Not too bad. I've got another 4 minutes. This cat is still doing my head in. All right, I'll talk this then. I'll do a bit of dimensional analysis to end this video. Try and fill in the other ones I haven't done, but we will go through some of them on Tuesday before the calculator paper, because we are into very much calculator papers here. Again, the sides that we want to know are this one and this one. No, you don't have to call them X and Y, but the sides that we do know are this one and this one. Get your scale factor, big one divided by smaller one. Boom. And remember, in fact, both these are times ones because both of them are going that way. Okay. I am jumping. Okay. Yeah. Scale factor. Nice one. We could do that without the calculator. Yeah. 25 divided by 5. No problem at all. Find the length of AC. Okay. Maybe we would need a calculator for that bit, because even though the scale factor is nice, dividing that by the scale factor isn't so nice. And then if they decide to go down like a more numeracy vibe, right, it doesn't have to be triangles. Have a look. We've got a 6 and a 15. We're looking for the words, instead of using the word similar, they've used the word enlargement. That's the same thing. If two shapes are similar, one is an enlarged version of the other. Calculate the height of the enlarged photograph. Well, it's whatever the scale factor is, 4 times whatever you work out your scale factor to be on your calculator. And finally, I am going backwards. My apologies. Have I got time to even go backwards? I'm sorry, I'm back and forth. We're going back to the page before area, which was dimensional analysis, and I'm going to absolutely rush it, but I will talk you more through it. And I have got, how long have I got to rush this through? A couple of minutes. We're okay. Right. If you see something that looks like this, it's weird. You have to, I've seen some people write things that you've either got to write length, area, volume, or none of these. Now, here's the deal. The rules are this. Ignore what we're looking at. These pluses and minuses, they split things up. Okay. What we're going to do though is we're going to cross out numbers. We're going to cross those out. We're going to ignore them, and we're going to cross out any reference to pi, because pi is a number, right? So if I go through this first and I go, right, 3.14, that can go. 2, that can go. Pi, that can go. Pi there, that can go. Right, so I've got rid of all my numbers and pi. Now we look at each part individually and we see how many letters are times in together. So d cubed is d times d times d. That is 3 letters times in together. 3 letters times in together is a volume. R squared h is r times h. Again, 3 letters times in together. That is a volume. So the answer is still a volume. Here, d squared is d times d. That's only 2 letters times in together. That's an area. HW is 2 letters times in together. That's an area. So my answer is an area. D on its own is a length. W on its own is a length. And H on its own is a length. So that's a length. There's no letters times it together. Now I've got rid of 2 and pi. All I'm left with here is an R. You can see it in there, hopefully. R on its own is a length. However, R squared in the second term is an area. Ooh, we've got a mishmash. When we've got a mishmash, the answer is none. And there's only 2 more I want to pick out to you. Brackets are an awkward one. The bottom one's really easy. Look, right? D cubed, that's a volume. D times D times D. And then DWH, that's also a volume.